Three.js can help you create amazing 3D effects and animations on your websites. In this course, Bobby Rowe will teach you how to use Three.js through building 5 different projects.
What's up, coders? Today we're diving into the exciting world of Three.js. Learn how to create insane 3D effects right in your web browser. We'll cover primitives, materials, textures, camera paths, post-processing, physics, and a lot more. Let's get started with some serious 3D action. Bobby Rowe here. I'm a seasoned code artist and software engineer with mad industry chops. For Three.js techniques, effects, code art, and more, visit my YouTube channel, Robot Bobby. Today's tutorial is laid out as 5 standalone projects, so you can skip around if you want. Basic JavaScript knowledge is recommended. Now, let's break it down. Getting started, we'll explore primitive shapes, lighting, and animation. Very nice. Next, create the earth with Three.js. Craft a beautiful, multi-layered earth using shaders, textures, and lighting. Epic. Then, fly through a wireframe wormhole. Animate along a camera path. Insane. Create a transition effect, a spectacular post-processing effect that's totally achievable. Awesome. Add physics with Rapier is the final project. Use this super fast, stable physics engine. Works great with Three.js. Ultra real. Since each project is standalone, feel free to jump to what interests you. Let's go. Have you ever wondered how the hell you could make 3D graphics on the web? Three.js is a powerful library that transforms code into awesome visual experiences. Whether you're a seasoned coder or simply curious, we'll start creating our own 3D scenes today. Since 2011, I've been creating interactive scenes and experimenting with Three.js. So are you ready to get to create some 3D graphics? Let's go! Today we're going to get comfortable with the basics of Three.js. First thing we're going to do is get Visual Studio Code if you don't already have it. This is the editor we'll be using today. The next thing we're going to do is to download the starter template. Come over here. The link is in the description of the video. And make sure you're on the main branch. Download the code. I'm going to download the zip file. And put it on my desktop. There it is right there. I'm going to unzip that, and I'm just going to create a directory called Three.js sketches so that I have them all in one place. Great. I'm going to drag this into Visual Studio Code. Yes, I trust. Thank you. And now here are my files inside running locally. The next thing I want to do is to be sure I have the live server plugin or extension inside of VS Code. This is going to allow us to very quickly see the changes to the code we make. It creates this tight feedback loop where we make a change and we see the change instantly, and we can code really fast, and it's fun and great. Get this. Got it? Great. Fire it up by clicking this little Go Live at the bottom of your screen. And here we go. Here's my scene. Not much happening at the moment. Let's go over to the code and take a look. Starting with the index.html. Not really covering HTML in this session. Main thing I want to point out is this import map, which makes it's a very convenient way to define your JavaScript import paths. I've defined 3 in JSM, and then here I'm importing the JavaScript file. This is where we'll focus today. Here, and first thing I want to do is get rid of this console.log, and instead write import star as 3 from 3. Great. Now I want to set up the scene. There's 3 things that Three.js needs for a scene: a renderer, a camera, and a scene object. Let's create the renderer first. Const renderer equals a new 3.webgl renderer. And we can pass in some properties. I'm going to suggest you pass in one property. Anti-alias is true. Just going to make it look a little bit better. Great. We want to set the size of the renderer. To do that, I want to grab the width and the height of the window. W equals window dot inner width. And const h equals window dot inner height. Now I can set the renderer width and height. See, renderer dot set, set size, width, height. Great. Also want to append to the DOM being the HTML page, document.body.append child renderer.dom element, which is the canvas element. Another way to do this is to create a canvas element inside your HTML and then use that when you set up your renderer. But I prefer to do it this way. Just let the Three.js handle the DOM element. Great, that's the renderer. Next thing we'll set up is the camera. Const camera new 3.perspective camera. We need to pass 4 things into the perspective camera: a field of view, an aspect, a near, and a far. Okay, let's define those. Const field of view is equal to 75 degrees. If I made this 5 degrees, the field of view would be very narrow. 90 degrees, it would be very broad. Const aspect, in this case, will be the width divided by the height. Const near is equal to 0.1. 0.1 units is when it starts rendering. Anything closer to the camera than 0.1 units will be invisible. Const far is 10. Great. Now, I want to scooch the camera back a little bit. We haven't added anything to the scene yet, but I want to scooch it back right now. Camera.position.z equals 2. Just a little bit further away so I can see what's at the center of the scene. Last thing we're going to set up, const scene equals a new 3.scene. Great. That's the core of this tutorial right now. Setting that up allows you to render something. Render. I got some crazy type in there. And then we'll pass in the scene and the camera. Boom! Isn't that just beautiful? Let me just close up this console and save it again. It's not beautiful. There's absolutely nothing there. Let's add something really quick. Three.js has built into it some simple geometries, primitives they're called, and we can just grab one of those and throw it in our scene. Let's do that right now. Const geo equals new 3.icosahedron geometry. It wants to have a size and a detail. We want to put a material on that geometry. Const mat equals new 3.mesh basic material. And this wants some properties, though only one I'm worried about right now is the color property. Let's say 0xCCFF. That's kind of a light blue color. And const mesh equals new 3.mesh. We're going to pass in the geo, and we're going to pass in the mat. And then we have to scene.add mesh. Ta-da! What the heck did we just do? Grabbed one of those predefined primitives from Three.js's library, grabbed one of the predefined materials from Three.js's library, the basic material, which doesn't calculate any lights at all, it just has a color. So it's kind of not even an object, it's just a circle, right? And a mesh, which is a container for both of the geometry and the material, and has a bunch of properties that you can use to move it around or rotate it or animate it. Someone would say animate. let's wrap our render call in a function that we can call again and again and again. And then as we update the scene, we'll see some animation. Function animate. And the way that works is through this API, request animation frame. Oh, that didn't work. There it is. You pass in the name of the function, and you're good to go. Don't forget to call it the first time, though. Animate, like so. Now it's being called every second. If I were to change the scale of the object, mesh.scale.setScalar, and we'll say math.cosine t times 0.001 plus 1.0. That's really complicated, but let's just add t here. T equals 0 to start with. And what the heck is happening? The animate this, when I call request animation frame, I'm getting a time difference passed in each time. We could see this more clearly if we were to console.log t and then pull up the console here. For free, when they call request animation frame, I get this value. I'm just using that to change the scale of my object. But enough of that. And enough of that too. Let's make our geometry look a little more interesting and then animate it, and then we'll be done for today. To make it more interesting, I want to change the material type. The basic doesn't interact with lights, so if I use the standard, the standard material, that's going to interact with lights. But there are no lights in the scene. Const hemilight equals new 3.hemisphere light. And I want it to be white on the top and black on the bottom. Scene.add hemilight. Cool. I mean, sort of cool. I want to change the color of my object to white. And also, flat shading is true. Look what that does. It allows you to see all the facets. And if I reduce the detail, you could see those or increase it. I think 2 is looking pretty good. To really highlight those different facets, let's add another geometry and see how that looks. It's going to be a wireframe geometry, kind of like this. Let's define the material first. Wire mat equals new 3.mesh basic material again, and the color will be white. Color is 0x 1, 2, 3, 4, 5, 6, and it's a wireframe material. Good. And we need a wire mesh. Const wire mesh equals new 3.mesh, and we can reuse the geo, the same geo, and we'll use the wire mat. And I don't see it because I need to scene.add wire mesh. And by default, it just puts it right in the middle of the scene, right on top of the other mesh. There's a problem. If I were to come in here and say mesh, I mean, it's not really a problem, but I want to animate the mesh. Rotation.y is equal to t times 0.0001, so a tenth of a second, or sorry, every 10 seconds. only the gray sphere is moving and the wire is not moving. To solve that, we can mesh.add. So I've just added the wireframe mesh as a child to the other mesh instead of a child to the whole scene. And now it'll automatically pick up the transformations you make, like rotations or scales or position changes. To make it look a little less flickery, I'm going to suggest wire mesh.scale.set scalar 1.001. Just slightly bigger, not 3 O's, 2 O's. See how it's a little less flickery now? I just scaled it up slightly. Great. I think we're doing well. Let's make it a little bit more visually interesting. Let's make it a kind of an blue color on top. 99FF and orange color on the bottom. Kind of a darker orange color. Isn't that nice? It would be nice to be able to kind of move around in the scene a little bit. The last thing I want to cover today is to use one of the add-ons to the Three.js library called an orbit camera. Orbit controls. Orbit controls. And we get that from jsm/controls/orbitcontrols.js. Good. We need to define it. Const controls equals new orbit controls. And we're going to pass in the camera and the DOM element. Render dot DOM element. Now, automatically we kind of get this interaction. Isn't that cool? We can kind of click and drag in the scene and use the scroll wheel or what am I using? My magic mouse. But it gets better. You can tweak it a little bit. Controls dot enable damping. Enable damping is true. And then set the damping factor. Damping factor and some small number. And now you still won't see that until you add this line to your animate method, controls.update. So every frame it's going to update the controls like so. Isn't that nice? That's it for now. Experiment with this. Test your knowledge by trying out some different primitive shapes. You could use cubes or torus knots, which are really cool. Find the teapot. That's inside of Three.js as well. There's a link in the description to read more about primitives. Try out different lights. Try a directional light, which is like sunlight, or a point light, or spotlights. Also, link in the description. Play with animating things. Animate the position, animate the rotation, the scale. You could change the color of the mesh or the color of the light. When you've done all these this experimentation, or at any time, go create a JS fiddle and share what you've created with others. I would love to see what you come up with. Today, let's discuss making a 3D Earth, a globe, using Three.js and JavaScript. Let's get started. I've got my basic template here, which is just the Three.js boilerplate setting up the scene and instantiating a cube geometry. Real quick, to get started, I like to add the orbit controls. I could have added these before we started, but why not just do it now instead? New orbit controls. Now, hang on. Let's see what I did wrong. Orbit controls.js. It's not what I did wrong. It's what GitHub Copilot did wrong. I'm going to slow down the rotation. So now it moves real slow and I can pick up the slack there. I like to add anti-alias as true here, because I just think that cube will look a little bit nicer. Why don't we replace that cube? We're going to make this an, let's call it an earth mesh instead of a cube. And we'll replace it with a icosahedron geometry. Out of the box, the icosahedron looks like that. It's got a radius of 1 unit and a detail of 1 as well. If we wanted to, we could drop that detail down. Sorry, I lied. It's detail 0. We could boost that up to 16. And now it's indistinguishable from a sphere. I like doing flat shading. It's true. So you can see that detail. We're missing one here. I guess it falls below the threshold of edges. I think for our sphere, 8 would be sufficient. Maybe slightly higher, 12. I'm not seeing a lot of chunky edges, so I'm happy with that. And then just comment that out for a nice smooth sphere. Cool. We've got a sphere. Let's put a texture on that sphere so that it looks like a planet, like planet Earth. Out on the internet, there is a website called Planetary Pixel Emporium. Here, and on it, you can check out Earth and download these texture maps for the color, for the bump, or like the mountains and stuff like that. A specular map to make the water shiny and the land masses less shiny. A city lights map, which is really cool at nighttime. Oh, I didn't mean to download that, but oh well. Cloud map, etc. As well as a bunch of other maps like the moon, like Jupiter, like the sun, etc. All right. I've already downloaded those maps. So let's try one of them out. We can get rid of this color statement and just say map is equal to new loader. But I want this to be instantiated instead. Let's call this loader and instantiate it here. Const loader is equal to a texture loader. And I have these maps already downloaded on my machine, but you'll need to either download the project files that we link to in the description of this video, or just go get those from that website there. I've got them in this directory called textures. And so I'll just use that. Textures, and the name is earthmap4k.jpg. And that did not work. Let's see what the console said. It said, hey, I don't know where that is. That's because it's not called earthmap, it's called 00_earthmap. Hey, there we go. Now we have a sphere with this texture mapped on it. All we had to do was tell Three.js that this attribute map would have this value, which is this texture loader, and it loads a JPEG. We could swap that out for something else. For example, let's get a new window here. I happen to have some of those other textures downloaded, like moon, Jupiter. Let's try Jupiter. So Jupiter looks like this. And now we've got Jupiter instead. And this is a 4K image, 4096 by 4096 or something like that. 4000 by 2000. So it's nice and detailed. I think it looks great. Let's go back to Earth and we can enjoy the detail of this too. Great. So we could just end there. There you go. There's your 3D Earth. But let's make this look better. We could add clouds. We could add a bump texture to give some relief, or like make the mountains look like they're coming up a little bit. We could also improve the lighting. Right now it's just kind of this ambient lighting. we could add this beautiful glow. If you ever Google an image, Earth from space, I guess, and then look at the images, there's this beautiful blue aura kind of all around the Earth, and we can get that too. Why don't we leave this open as reference? So let's get started with that. Let's get the rotation going like that. The Earth is kind of tilted on its axis, isn't it? I'm not sure that this photo reflects that really well. Or I'm not even sure this is a photo of the Earth. But there's a tilt. So to emulate that, I'm going to create a new, let's call this Earth group. It's a new group. And now instead of adding the Earth to the scene, I'm going to add it to the Earth group. And I'm going to give this rotation. So Earth group dot rotation dot z is equal to negative 23.4 times math.pi divided by 180. I think, what is the Earth's axis angle or tilt? And does it say here axial tilt? That defines axial tilt, but what's that? The Earth's, look at this, 23.4. Okay. So I want to temporarily kill the rotation. Come back here. And does that look right to you? Kind of like that? Kind of? I'm going to say, yeah, it looks right. Because I don't know. And now I want to turn on the rotation Y, and now it's spinning along that tilt. Great. Should we add the stars next, or should we beef up the Earth next? I think adding stars would be good. I've pre-built my stars. The way, my method for adding stars, there's a couple of different ways. I like to just create a dome of points. And to do that, I've written up, let's hide this thing here. Let's import get star field from my get star field. And I think that'll work without breaking anything. And now I'll go over this code in a second. All I have to do is const stars is equal to get star field, and then scene.add stars, or scene group. Just scene.add stars. That's all I have to do. And now if I pan out and pan around, I've got these stars all around. And if I want to, I could say num stars is equal to 2000. And it'll give me a lot more stars. How about 20,000 stars? Way more stars. Why don't we look at that code real quick? I think 20,000 is probably too many. I like 2,000. I can't remember what it defaults to, but some small number, like maybe 200. Here's that get starfield file. It's a JavaScript module. I'm exporting this function, which is just to get the star field. There's the default number of stars. It's 500. I'm going to go over this later. For now, let's just leave it at that, because I want to build this Earth first. So now we've got our Earth tilted on its axis. Let's fix the light real quick. Comment this out, and now well, not everything, just the Earth is black. And let's create a new directional light. Except I want it to be called sunlight, because that makes sense to me. And scene.add sunlight. Now it's just from overhead. Instead, I want to move it over to some theoretical center of our solar system. Sunlight dot position dot set. That's moving it on the z-axis. I want to move it on the x-axis too. That's pretty good. Negative 0.5, slightly lower. I like that better. Do I even need to move it on the z-axis at all? I kind of do, actually. I kind of do. All right, I've moved the sunlight just the way I like it. And now the Earth is kind of orbiting around. I think it should be positive 0.5. That makes more sense to me. Great. Now, the dark side of the Earth is truly dark, as it would be in space. Why don't we add lights? To do that, I'm going to create a new mesh. I'm going to call this lights mesh. And this is going to be... this is okay. Thank you, GitHub Copilot. I don't like this nested material here. So I'm going to pull it out. I'm going to call that lights mat. Okay. I'm reusing that same icosahedron geometry. So const lights mat is equal to, and paste this material. It's already digging into my textures directory and pulling out this lights mat material. Let's turn that off for now. And in fact, just to kind of show the simplest implementation of this, color is equal to green. Okay, and let's add that to our Earth group. Earth group dot add lights mesh. Okay, now, oh my goodness, look at that. What is going on? How cool is that? I love these happy accidents. So let's make this transparent, and let's make the opacity 0.6. So now it's the same thing. It's just a little bit more transparent. What's going on here is that green sphere I just created is sitting on top of the Earth sphere, and the Earth sphere is rotating, and you're getting the interplay of those vertices. If I drop the detail here, I'm going to break that out into its own const detail, and I'm going to drop this down to 4. You can really see those interacting better. Or 2. I like that look a lot. This is a complete aside. Let's go back to 12. And I'm going to want that to rotate as well. Let's say lights mesh is equal to that too. So now they're both moving together, and we get rid of all that Z fighting. Now let's get rid of the color. And I don't really care that it's transparent anymore, and let's drop the map on there and see how it looks. Oh, so now this is that texture that I downloaded from that Planetary Pixel Emporium that looks like this. Here's that texture, and that's mapped to this icosahedron. But I want to be able to see the Earth underneath it, so I'm going to change the blend mode to additive blending. Now, wherever that previous texture is bright, we see it, and wherever it's dark, we see the lights. How cool is that? Well, we're going to see the lights in the bright parts too, but I'm okay with that for this example. Great. In the time remaining, I want to add a couple more things. A cloud mesh. Let's just add that real quick. Const clouds mat is a mesh standard material, and it's loading my high-res clouds. I'm going to disable all this stuff. Let's say earth group dot add my new mesh, which I didn't define yet. Whoops. Clouds mesh. Yeah, that's what it is. Same situation. Let's get that clouds mesh moving around. Thank you. Oh, isn't that nice? This is the clouds mesh. Let's use that additive blending technique we used just a moment ago to get it to sit on top. Anywhere the image is light, And also, you know what else I want to do is to elevate it a little bit off of the mesh. So const, oh no, I don't need a const. I need cloud mesh. Dot scale, dot set scalar, and I just want it to be slightly larger. Oh, that's not good. It's clouds mesh. Kind of like that. Nope, that's still no good. Why? Oh, because I had it written out as coulds mesh. I think that looks good. But obviously it doesn't. Clouds mesh could not be defined. Oh, I see. It's in my animation loop. That's what you get when you code rough and fast. I've just picked it up off the earth a little bit. You know what would be fun to play with is to go in and have this cast shadows. I'm not going to mess with that right now. Instead, I'm going to keep it moving. Let's get rid of this hemisphere light. We don't need that. I could make this semi-transparent. That's up to you. I don't see a big difference. I'm not making the light semi-transparent. We're almost done. The last thing, and my favorite part, is to add a glowy atmospheric look around our model. And to do that, we're going to use what's called a Fresnel shader, which is spelled Frenzel, I think it is. So, hang on. Fresnel. So I'm gonna import this. How am I doing that? Oh, I see. I'm doing it differently for this one. I have to import that Fresnel material. And I'm going to create a new mesh on top of the clouds mesh. Whoops, I'll do it here. This is a Fresnel mat. And then I'm going to create a Fresnel mesh, or a glow mesh, if you will. I will. Glow mesh. And now earth group dot add glow mesh. And I need to manually rotate it, because that's how I'm doing this. It's kind of laborious. I don't see it at all. Do you? I don't see it, and I think that's because I need to scale it up a little bit. I'm going to scale it up to, oh. Let's do it here. 1.01, and let's see. Oh, I still don't see it. Why not get Fresnel mat? Let's see if there's any errors. There's no errors. We got our Fresnel mat, our oh, that's why. Let's actually scale up our glow mesh. There it is. When you zoom in, you can kind of see the edges of our icosahedron. But isn't that glow nice? Oh, let's have this move slightly faster. The clouds will orbit a little bit faster so you can see them kind of passing over. That's a little bit too fast, I think. Tweak to your tastes. There you have it. The iconic wireframe wormhole effect. Armed with nothing but Three.js and some free time, we're about to embark on an adventure through code. Let's bend the very fabric of virtual space with our bare coding skills, from animating cameras to dance along a predestined path to summoning the Unreal Glow effect. So grab your flaming hot Cheetos and a cup of decaf coffee and join me on this interdimensional jaunt through the wireframe wormholes of Three.js. This is what we're building. We're going to build it in a few different steps, starting with loading the path data and creating a spline from that. A spline is just a representation of a line in 3D space. And this one, as you can see, kind of snakes and curves around in an interesting way. And we'll use that as the basis for tube geometry. We'll then add an edges geometry to get this look that you see on screen now, where there are fewer lines in the tube, in the wireframe. After we've done that, we'll add in some boxes, just so there's something in our path that we're flying past. And lastly, we'll add a glow effect to give it even more of that retro look that I love. Let's jump into it. starting from here. Just the basic boilerplate. Let's just go over what that is. Got our imports at the top. I'm importing the orbit controls as well, so I can kind of drag and move around. We set up our scene with our boilerplate, the camera, and the renderer. And I have a cube here. I'm going to pull that cube out. No longer need that. And save it. Now we have an empty scene. Let's load in our path data. I'm going to import spline from spline.js. Let's look at what's inside of spline.js. Here at the top is the curve path. Just a collection of 3 floating points per vertex. So I think there's like, what do you think? Like 35 vertices there that represent this path that's kind of winding through space. I'll load it up and show you. Before I do though, we take those points and we convert them to 3 vector 3s, and that will be the basis for this Catmull-Ram curve, which is really handy. It allows us to interpolate smoothly between those points. And then we return that so that it's loaded in here. Console.log spline. This is what the data looks like. Whoops. Here it is. And it's got these 37 points. First thing, let's see what that looks like. I'm going to ask GitHub Copilot to create a line geometry from the spline. It's going to get 100 points, then create a new buffer geometry and set the vertices for that from the points. Create a new line basic material and make it red. Create a new line from that geometry and material and add it to the scene. I thought it was red, it was really green. And here is what that line looks like. Kind of like a crazy roller coaster or something, just floating in space. Cool. Let's comment out that line. And now let's create a tube geometry in the same way. So we'll create the geometry, passing in the spline, defining the number of divisions along the length. The radius is this value here. There's the number of divisions along that radius, the radial divisions, and then finally, is it closed or not? That's true. A tube material. We'll use a mesh standard material to start with. The color will be, how about we'll make it an off blue color, kind of like a baby blue color. Make it double-sided because we're in the inside of this tube eventually. And make it wireframe. Oh, and then add it to the scene. Oh, actually create a mesh and then add it to the scene. So the tube is going to be a new mesh with the tube geometry and tube mat. And we'll add that tube to the scene. Great. There is our tube geometry. And let's see. I just want to see if it isn't double-sided, if I go inside, can I still? Yeah, I can still see it because it's wireframe. This will be important to have it double-sided if it weren't wireframe, right? Because I'll go inside and there's just nothing in there. Let's make it double-sided again. Now, there's this interior of the tube. That's kind of what I want. Kind of doesn't matter though. I'm just going to leave it wireframe. Here's why. I'm going to create an edges geometry too. Actually, let's fly through first and then create the edges geometry. To do the fly through, I want to create a function, update camera. This is going to, it's going to progress along that curve that we created a moment ago. And there it is. Thanks, GitHub Copilot. Now, instead of using time, though, our date.now, I'm going to use t that I pass in here. Update camera and pass in t. I don't know if this is more efficient or less. It's just a convention I'm used to doing. What just happened here? Every time I call this request animation frame, it's going to pass in a timestamp. For the first time I called it, though, I'm giving it a default value of 0. Then I'll pass that timestamp into the update camera method. I'll reduce it by this, what is this, like a 1/10,000th or 1/20,000th or something? I don't know. I'm going to grab a point along that spline. The point needs to be between 0 and 1. This modulo operator is going to give us the remainder of dividing by this number here. So let's say time is 10 and we divide by 20, we get 0.5. It's only going to give me the remainder using this operator. And then I divide that by the loop time. Hang on, I tell the camera to move to that position and look at this position, which is slightly ahead, like so. And now we're not animating because it's too slow. Let's move it a little bit faster and a little bit faster. And if I chop this down, it should go twice as fast. So that's the core of this tutorial, is creating a tube and then attaching a camera to a path inside of that tube and moving along. It's still moving kind of slowly, isn't it? That's a little bit better. Is that less clear? I think it should be that. Let's move it a little bit faster. So I want to modify the look of this wireframe. Right now we're seeing every single triangle, and instead I only want to see some triangles, like remove those diagonals if possible. And to do that, I also want to change that. Right now I'm getting this shaded effect. Let's change the lighting first. Hang on a second. Before I do the edges, I'm going to take off that hemisphere light, and everything disappears because there's no light in the scene now. And this material, I'll make a mesh basic material. Boom, now everything's back and there's no shading at all. And let's add some fog to the scene. This fog X2 is the way to go. The color of the fog and this, I don't know what is this? Can you give me a hint here of what that is? It's the density. Okay, but here's how it looks. I just love this effect. Edges geometry. This is what that looks like. Create edges geometry. We'll create an edge geometry. What is this value here? 0.2. I think this is like a threshold. Anyway, we'll come back to that. Const lines. There's the line material I'll use for the edges geometry. Let's make it white the same. 1, 2, 3, 4, 5, 6. And then create the line 2 from line segments. Why is that line 2? Oh, because I'm already using the line up here. How about tube lines? And then lastly, let's scene.add tube lines. That's not what I expected. Edges geometry. I'm using the edges in the mat. Let's hide our wireframe for a second. Yeah, that's not at all what I expected. Oh, I bet it's because of this threshold. Yeah, it's not. Shoot. I'm going to have to look at the previous example because this is weird and I don't understand what's happening. Edges geometry. Let's have a look. So here, where's my edges? I don't know. Oh, here it is. I'm using point to see align material, align segments, and then adding that line. Oh, interesting. It looks identical, doesn't it? Edges, geometry. That's the difference there, is this tube geometry. It's not different though, it's the same. Line material, line basic material, line segments. Huh, I wonder why it looks so crappy. Why does it look so crappy? 0.1, 1.0. Oh, that's really odd. I don't understand. Hang on a second. What if I just pull back? Oh, and let's turn off the fog for a moment. See what's happening. Yeah, I didn't expect that to happen. That's just weird. That's just weird. Geometry. Oh. Oh my god. Alright. So here's what I did wrong. I passed in the line as the basis for the edges geometry instead of passing the tube. Duh. Let's do that instead. Tube geo. I think this will look better. Yeah. And then update the camera again. Yeah, that's what I was expecting to see. Let's turn back on the fog. Now our wireframe wormhole has a different look and feel. I really like it. Let's add a bunch of boxes. What we're going to do is, using that path, we'll traverse the path, move along the path, and create boxes in it and put them on the path, but offset a little bit. So they're not right in the middle, but kind of on the side. Well, let's see here. We'll do it below all the tubes and edges, right above update camera. Let's define the number of boxes, which will be 45 or 55, slightly more. And we'll do a for loop. Actually, I like that size as well. Now, box geometry, thank you. That's the box material. I'm not going to use that because the box is going to be a box helper. So for let I equal 0, while I is less than num boxes, I plus equals 1. We want a box helper. Are you giving me a box helper here? No, you're not. You're giving me a box mat and a box. Oh, I guess I need that for the box helper. Here's the material in the box. No mystery there. I'm defining the box geometry outside of the for loop because I don't think I need to redefine it each time. This might look familiar. We're grabbing a point along, or I divided by num boxes, so all along the point, evenly spaced, but then offsetting it slightly. Again, using this modulo 1 to get a number between 0 and 1. Now we are going to grab a position along that point and then set the offset a little bit of randomness and then set the box position there. Also a little bit of random rotation and then add the box. We're using basic material, so we should see it just fine. There are those boxes. Const box, or just helper. Helper equals new 3.box helper, and we'll make it yellow. And scene.add helper. So, oh yeah, isn't that interesting? It's not rotated. Can I rotate the box helper? Helper dot rotation dot set. I I can't see. I can't see. Thank you. Does that work? Ah, it doesn't work. I guess you can't rotate those box helpers. That's too bad. I could use edges geometry. Sucker. Let's do that. We'll need a material and line segments, and then it's just a lot more lines of code than the helper. You know what I'm saying? I could define this line mat outside, but I kind of want the color to change each time. And instead of tube lines, this is box lines. Hang on. Box lines. Format that. Oh, it blew up. Why did it blow up? Because I'm using this tube geometry. I need to use the box geometry. And that should do it. It didn't do it. Did I define color? Can I just make it yellow for now? Okay. I'm not seeing my box lines. Oh, I need to set the position, right? And the rotation. Box lines. So there's the position and then the rotation. Oh, isn't that interesting? Box lines. There. And now get rid of the box. And now we just have the lines. And we have this nice rotation too. Cool. Last step, to add the glow. I do love the glow. I'm going to just copy and paste the Unreal glow effect from my previous example here. And along with it, I need to copy and paste the effects composer and this render pass as well. I wonder if I really need that render pass or render pass. Let's have a look. Here, before I define the geometry of my scene, I'll just paste in this post-processing, where I'll create the render scene, which is the equivalent of what you're seeing now, just the render. And this bloom pass, that's where the magic happens. It's the width and the height of the screen. I actually don't know what all these params are. These two are the ones I play with the most. And create a new effects composer and add it, and that composer will replace our renderer here. And then we get that glowy effect. Maybe we want to change the color of the lines on our tube, on our edges. Right now they're white. We could make them red. Oh, that didn't work. Because I'm not showing the tube anymore. I don't think I need this tube or the tube mat. Are you using the tube mat for anything? I'm just using the geometry now. And this is the color that I want to change. How's that look? Pretty cool. I like this effect where each box has a different color. Let's do it like this, where I define the color. Whoops. Const color is equal to a new color. And I'm looping here. P is the position along the spline, so it's going to give you a value between 0 and 1 for the hue based on P, starting at red and progressing all the way past purple back to red again as you traverse. And this is what that looks like. I could make it go backwards, 1.0 oh, that's really weird. 1.0 minus, so it'll start at red and go to purple and cycle through blue and green before it gets back. And should we really crank up the speed? Let's double the speed. Whoosh. Cool. I encourage you to use what we've created here as the basis for your own explorations and your own variations. Use different geometries inside of the tube instead of just boxes. Load in some models or use other primitives or animate things. Load an animated model and move it along the spline as well. Also experiment with different looks and feels for the tube geometry, you could use a different type of a shader so that it had flat shading. It's all faceted, and you could use lights inside of there for a cool effect. You could even color the vertex of the vertices of the geometry. That might look really cool as well. But yeah, thanks for tuning in. Today I want to talk about a transition effect inside of Three.js. Let's jump right into it. This is borrowed heavily from an example on the Three.js website created by Fernando Serrano. I hope I'm saying his name right. And it features two different scenes which are smoothly transitioned between using this really cool effect. So I'm going to return it back to the state that looks more like the example, kind of like this. I modified the scenes so that it has the same geometry in the same orientation, so that when you do the transition, it appears that the material just like grows on the object, and then it decays and disappears from the object. So there's like a coherence between the objects. That's not necessary. It's just a kind of a cool look I was interested in. I changed the lighting as well. I added this hemisphere light. Let's make it a little brighter. And let's make these objects a little bit smaller. Let's talk quickly about the setup. The example on the Three.js website is all a single HTML file with embedded JavaScript and shaders. And I found it kind of difficult to understand. I pulled it down, removed the stats and the GUI, and just tried to break it up by function. And let's just walk through what I came up with. Here's the basic scene where we just kind of set things up. There's going to be a single renderer shared by all three of the scenes that are set up. Okay, we got a couple of materials which the entire scene will use, and this transition. So that's it. This animate loop. Okay. Let's look at the FX scene. That's the first kind of scene that we're using. All it's doing is creating an instance mesh. Okay, and then in this case it's an icosahedron. I could change that to box geometry and change that to size. And now we've got boxes instead of icosahedrons. Also cool. What if I made it a tetrahedron geometry? I'm actually not sure what that takes. Oh, it takes whoops, I'm making a mess. Oh, I see why it's confused. So tetrahedron geometry takes a radius, which will be size, and then a detail. Let's make it 0. Great. Bunch of tetrahedrons. Also cool. What if we jack that up to 5,000? Wow. Made them slightly smaller. And the effect comes on. I don't get tired of that. I could just watch that effect all day. Let's go back to the icosahedron. And the size is 0.5. And we have 5,000 of them. Whoops. There we go. I kind of lost track where I was. This is the FX scene where we just take a material, put it on an instanced geometry, and then we set up our scene. We're using this shared renderer. The render function's a little bit different because there's this frame buffer object, the render target. I don't really know what I just said. I just know this is like I think this acts as like a container for the render, and then you can tell the renderer to use that container or another container use that render or another render. I hope that makes sense. That's my very loose understanding of it. This transition handles that effect. It creates a plane. It textures that plane with those scenes, or the blending of those two scenes. It uses a texture. Here's one of the textures. Here's another. Sorry to see, isn't it? And here's another. That texture, through some alchemy in this shader, is transitioned to and from the two scenes. Again, apologize for the loose definition. I just know it works. If you swap in a different texture, you get a different effect. That's all I got. The rest is just kind of messing around with those FX scenes to try different things and see what looks cool. I added this color transition effect. You could change this to be set HSL and give it math.random for the hue and comma 1.0 for the saturation, 0.5 for the value. And now we've got a bunch of random colors. I use this needs animated color property when I set it up. Here, I only wanted the scene that had the material that's solid, the non-wireframe, to have the random colors, because otherwise I'd have random colored wireframes, and I didn't think that looked interesting. It's actually not bad, but that's not what I wanted. I wanted a single color wireframe. And maybe that wireframe is white. Like so. Also really nice. This example has code to set the background color as well. I think it's called clear color. Yeah. And we'll make the clear color an off-white. So that now when we go to the wireframe scene, it doesn't work. Shoot, I messed that up. Not sure how exactly I messed that up. Let's see here. Transition, it's in the FX scene, clear color. Clear color. Huh, I thought I did that correctly. And the index. Oh. It belongs in the scene. That's why I messed it up. Here we go. Off-white. Now when we transition to the wireframe, it kind of inverts the whole thing. Yeah. Check this code out on the Three.js website as well as on my GitHub. Play around with it. I'm going to try some other things with this too and see what I come up with. But I just love this effect. I could watch it all day. We're mixing the Rapier physics engine fast, stable WebAssembly module with Three.js. With a few lines of JavaScript, we'll bring dynamic collisions and forces to your Three.js scene. From laying down our foundational setup to linking collision bodies with our 3D objects, this lesson will be dynamic. Literally. Strap in, sharpen your minds, and let's get the physics party started. Okay, we're going to start simple. A Three.js scene with a single object in it and some background sprites. From here, we're going to add a bunch of geometry, in this case an icosahedron. Then we'll wire up mouse controls and we'll have a little light ball moving around. Once that's all in place, we'll add Rapier physics engine so that the objects are colliding with each other and with the mouse. And lastly, add some post-processing, some Unreal Bloom for a really cool glowy effect. Let's get started. Here's our basic boilerplate where I set up the renderer and the scene and the camera. I'm creating a container for the mouse position, and now I'm just creating a bunch of bodies. So let's up that to 10. Let's make these a little bit smaller. I'm adding this mouse ball as well. Before we move on, let's just look at what getBody and getMouseBall give to us, because there's a lot going on here. I'm going to pick a random position in space between range and half range. So in this case, between -1 and 1. I'm going to make some geometry and then add a wireframe geometry to that and then return that. So that's all that's doing. The getMouseBall is the same thing, only does this have an update method too? No. Only I'm adding this update method wherein it's just moving or where the mouse moves. Let's add that update method here. And let's call this, what's it called? Mouseball.update and pass in mousepause. So now nothing happens. Why not? I'm not sure why not. Oh, because of this. Already that's really cool, right? Just moving this light around. I'm not sure if I made it clear, but when I created this mouse ball, I'm creating a little point light and attaching that to the ball. So as it moves around, you get this cool lighting effect. Great. Now, the next thing to do, we've got a bunch of geometry. We wired up some mouse controls for interaction. Let's add the physics. First thing we'll do is import the Rapier physics engine from this CDN up here. Next, I'm going to initialize the Rapier physics engine, define gravity, and create a world. I don't know why it's let, it should be const, right? And create a world passing in that gravity. Lastly, down here in our animate method, we'll call world.step. So that's hooked up. Not much has changed because none of these objects in my scene have any physics associated with them. Let's change that. I've already created the methods to link the Rapier physics engine's rigid bodies to the Three.js geometry. So let's use that instead. I'm going to pass in Rapier and world. Same here. Rapier world. And it doesn't look much different. Let's take a look at that setup and then fix that as well. So first, let's get the mouse ball. It's the same code as before, where I simply create some geometry and a material and a mesh and add it to and add a light as well. But this time I'm also setting up a rigid body. The way to do that with Rapier is to pick a rigid body description type. There are 4 types. I'm only familiar with 2 of them because I'm only using 2. This kinematic position based is useful for interactive objects, like objects that are going to track the mouse move, for example. I create a rigid body using that description, and I create a collider as well. In this case, it's a ball collider set to the size of the ball. Oh, times 3, because I wanted it to have more of an impact, so I scaled it up. Lastly, I have this update method, which is just going to set the mouse rigid body to the mouse position and then update the mesh too. That's it. Real quick, looking at the get body, same as before, only now we're adding a rigid body description. This one's dynamic, so it's not controlled by anything but the simulation. Creating a rigid body with that description and a collider, another ball collider, and I'm setting the density in this case. The density, we'll play with that in a bit to see what it looks like. And then creating a collider. There's the geometry setup. And lastly, I've got this update method. I am resetting all the forces, and I want to I've defined a point at the middle of the scene that everything will be attracted to. I'm calculating the position from the current ball to the center of the scene. That's the sub. I'm like subtracting the position from the center position. And then I'm adding force to that, the result of that subtraction, and scaling it down a little bit. Can't remember what true means exactly. And then I'm setting the position of the 3.js object as well. Let's call that update method inside our animate here. Let's say bodies.forEach body.update. And just like that, all the balls are being pulled toward the center of the scene, and then they're colliding with this light. Isn't that just really cool? I just think it's so good. Now it's time to add the post-processing. The thing to note here is this Unreal Bloom pass. Okay, here's the bloom pass. I'm going to set its threshold and strength and radius. I don't know what these are. Just play with the values until it looks good. The last thing to do is with this effects composer, that's going to replace our renderer in this method here. Oh my god, it's really, really glowy. Let's turn down the sprites in the background. Let's tone those down. And then let's dim down the hemisphere light as well. Hemi light dot intensity is equal to 0.2 instead of 1. Woo! How cool is that? It's really glowy. Is it too glowy? Let's look at this value here. Maybe it's not glowy enough. We could drop the brightness of the point light if we want. Set to a 2, let's set it to a 1. Still looks really good. I kind of want to play with the threshold to see if we can make the glow look more glowy. This should be a lot more glowy. Huh. It's actually okay. It's not that bad. I'm going to make this 10 times more glowy. That's pretty cool, but it's not really what I wanted. Something to play with. Change the color of the wireframe on the balls. Right now they're black. Let's make them white. And that changes things significantly, doesn't it? Too much. That looks kind of cool too. There's something too chattery about the white though. What if I dim it down to like, I don't know, 4, 5, 6. That's pretty cool. I think I like the black better. What does red look like? No, it's way too much. And that's just interesting, but not quite right. Oh, that's pretty cool. So, some things you can try. You can tweak the settings all day and see what else cool you come up with. Also, try adding other shapes like cubes or text geometry or other simple models. Try creating a simple game. Or come up with another interactive physics simulation. As always, thanks for coming by, and please leave a comment below with your thoughts or any suggestions you might have or questions. Thanks so much. See you next time.